The Persian Gulf, 2,147 hours local time, 81 nautical miles southeast of Bahrain, in water that is 73 meters deep and still radiating the heat absorbed from 14 hours of direct subtropical sun. The USS Dwight D. Eisenhower Carrier Strike Group is conducting sustained operations in the confined geometry of the world's most strategically consequential enclosed sea. The Persian Gulf is 615 nautical miles long and averages 150 nautical miles in width, dimensions that place every point in the Gulf within range of Iranian coastal systems, and that compress the maneuvering room available to a carrier strike group to a fraction of what the open ocean provides. The USS Dwight D. Eisenhower, CVN-69, a Nimitz-class carrier displacing 104,000 tons, is the largest warship ever to operate in these waters on a sustained basis, and her presence here is both operationally significant and operationally constrained. Significant because it demonstrates the American commitment to freedom of navigation in the Gulf and the Strait of Hormuz approaches, constrained because the Gulf's shallow depth, restricted width, and proximity to Iranian territory reduce the strike group's tactical options in ways that open ocean operations do not. The Iranian aerospace forces have studied these constraints for 40 years. They understand the carrier's maneuvering box. They understand the sensor coverage gaps produced by the Gulf's shallow acoustic environment. And they have been developing, testing, and now deploying a weapon specifically engineered for the Persian Gulf's confined geometry, the Shahed-238. The Shahed-238 is not the Shahed-136 that has appeared in previous engagements. The Shahed-136 is a delta-wing piston-engine one-way attack drone with a cruise speed of approximately 185 kilometers per hour. Slow enough that every defensive system in the American inventory, from CIWS to small-caliber deck weapons, can address it given adequate detection range. The Shahed-238 is a different engineering proposition entirely. Where the 136 uses a piston engine derived from commercial aviation power plants, the 238 uses a miniaturized turbojet. Iranian state television showed the aircraft publicly in late 2022, and defense analysts immediately recognized the significance of the engine swap. A turbojet-powered Shahed cruises at between 550 and 650 kilometers per hour, 3 to 3.5 times faster than its predecessor. The compressed timeline that speed creates is not a marginal improvement in the weapon's capability. It is a qualitative shift in the defensive problem it presents. A Shahed-136 detected at 25 kilometers gives a failing CIWS operator approximately 8 minutes of engagement time. A Shahed-238 detected at the same range gives that same operator approximately 2 minutes and 45 seconds. In a saturation attack, those 5+ minutes of difference determine how many contacts the defense can address before the first one reaches the ship. Iran has been building Shahed-238 stockpiles since at least late 2022, and the intelligence community's best current assessment, based on satellite imagery of production facilities at the Shahed Aviation Industries Complex near Isfahan, signals intelligence collection on procurement activity, and human intelligence reporting from the Iranian defense industrial sector, places the current inventory at between 800 and 1,200 airframes. Tonight, 42 of them are in the air simultaneously, launched from 3 separate positions along the Iranian coastline between Bandar Abbas and Bushehr, in a coordinated wave designed to approach the Eisenhower strike group from 3 distinct bearings: 045 degrees, 310 degrees, and 270 degrees, arriving within a 27-second window. The launch sequence was staggered to compensate for the different ranges from each launch position to the strike group's projected position, producing the near-simultaneous arrival. It is the most sophisticated Iranian one-way attack drone employment ever attempted, and it reflects operational learning from 2 years of Shahed-136 engagements in which the single-bearing approach made defensive allocation straightforward. The AN/SPY-6V3 radar aboard USS Leyte Gulf, CG-55, the Ticonderoga-class cruiser positioned 18 nautical miles northwest of the Eisenhower, acquires the first launch events at 21:47 hours and 12 seconds. The SPY-6V3, the ship-based variant of the air and missile defense radar, fitted to Leyte Gulf during her most recent modernization cycle, provides an air search sensitivity improvement over the legacy SPY-1B that translates against a target with the radar cross-section of a Shahed-238, approximately 0.04 square meters, to a detection range of 67 nautical miles under the current atmospheric ducting conditions in the Persian Gulf. Detection at 67 nautical miles gives the engagement timeline a fundamentally different character than detection at 25. At 650 kilometers per hour, 67 nautical miles translates to approximately 6 minutes and 10 seconds of engagement time from first detection to hull range. 6 minutes and 10 seconds across 42 simultaneous contacts from 3 bearings is not comfortable. It is workable. The E-2D Advanced Hawkeye, Oracle 9, orbiting at 21,000 feet, 55 nautical miles southwest of the Eisenhower, acquired the launch signatures 17 seconds before the Leyte Gulf's SPY-6. The AN/APY-9's look-down geometry against the low observable launch signatures of the Shahed-238's turbojet provided slightly earlier acquisition than the surface radar. Oracle 9 transmitted the alert at 21:46 hours and 55 seconds. The tactical action officer aboard Leyte Gulf received the combined E-2D and SPY-6 contact picture at 21:47 hours and 14 seconds. His Aegis Baseline 9.C2 fire control computer had already begun computing engagement assignments before his voice acknowledgement completed, but tonight contains something that no previous engagement in any water has contained. Mounted on the starboard side of USS Leyte Gulf's aft deckhouse, in a housing installed during her 2022 to 2023 modernization period, is the high-energy laser with integrated optical dazzler and surveillance system, HELIOS. The HELIOS is a 60-kilowatt solid-state fiber laser weapon system developed by Lockheed Martin under a contract awarded in 2018 and delivered to the Navy in 2022. It has been tested against surface and aerial targets in controlled environments. It has been tested at sea aboard the Leyte Gulf during operational evaluation periods. It has never been used in combat. Tonight, its combat debut occurs against the most demanding threat profile ever presented to a shipboard directed energy weapon. 42 Shahed-238 turbojet drones approaching from 3 bearings in a 27-second arrival window. The HELIOS weapon system operator, a fire controlman first class, who completed the HELIOS operator qualification course at Naval Weapons Station China Lake 18 months ago, and has accumulated more simulator hours on the system than any other operator in the fleet, has been at his station since 2,103 hours, when the evening's intelligence brief elevated the threat assessment for Persian Gulf operations to its highest level. He has run the system's built-in test 3 times since manning his station. The optical bench is aligned. The beam quality monitor shows 97.4% coherence. The cooling system is at operating temperature. He is ready. The HELIOS engagement doctrine for a saturation attack scenario was developed through 18 months of analysis and simulation at the Naval Surface Warfare Center in Dahlgren, Virginia. The HELIOS fires a continuous wave laser that must dwell on a target for approximately 3.1 seconds to achieve reliable incapacitation against a Shahed-238 class target under current Persian Gulf atmospheric conditions. The specific dwell time determined by target aspect angle, atmospheric humidity, which increases absorption of the laser's near-infrared wavelength, and range to target. The Helios slews its beam from one target to the next in approximately 0.4 seconds, giving an effective engagement rate of one target per 3.5 seconds, 17 targets per minute, against contacts within its effective engagement range of 5 nautical miles. It is a terminal defense layer, not an outer defense layer, and it is the first directed energy terminal defense layer ever deployed on an American surface combatant in combat. The engagement sequence begins at 2,148 hours and 2 seconds, 6 minutes, and 8 seconds after first SPY-6 acquisition. Leyte Gulf fires the first SM-2 Block IIIB at 21:48 hours and 04 seconds. The CEC network allocates engagement assignments across USS Mason, USS Nitze, and USS Cole, the 3 Arleigh Burke destroyers in the screen, each assigned a sector of the approach-bearing coverage to prevent engagement duplication and ensure every contact has an assigned interceptor. The SM-2 Block IIIB proximity warhead is effective against the Shahed-238's airframe and engine bay, and the drone's non-maneuvering cruise profile makes the fire control solution straightforward. The first intercept occurs at 21:49 hours and 31 seconds at a range of 44 nautical miles from Leyte Gulf. Then the second. Then the third. The CEC network maintains continuous track updates on all 42 contacts throughout. The composite picture updated every 0.4 seconds from Oracle 9's APY-9 radar and the SPY-6 simultaneously. Between 21:49 and 21:51 hours, the SM-2 engagement layer addresses 21 of the 42 contacts, the outer defensive ring working systematically through the highest priority contacts on all 3 approach bearings at once. 21 SM-2 intercepts, 21 contacts removed from the threat picture, 21 remain. The ESSM, Evolved C, Sparrow Missile Block II, engages beginning at 21:51 hours and 14 seconds, as surviving contacts enter its optimal engagement envelope, between 25 and 10 nautical miles. The ESSM Block II, with its active radar seeker and CEC data link mid-course guidance, is specifically optimized for the small, fast, low-altitude target profile the Shahed-238 represents, a contact category for which the Block II's seeker improvements over the original ESSM were explicitly designed. The ESSM engagement layer addresses 11 additional contacts between 21:51 and 21:53 hours. 11 more removed. 10 remain. At 21:53 hours and 27 seconds, the first Shahed-238 contacts cross the 5 nautical mile range threshold that places them within the Helios engagement envelope. The weapon system operator has been tracking the surviving contacts on his targeting display. A fused picture from the SPY-6 and the Helios system's own AN/KAX2 electro-optical tracking sensor. Since the SM-2 engagement began, he selects the nearest contact on the 310-degree bearing. The Helios beam slews 47 degrees in 0.3 seconds. The thermal tracking system locks the beam on the Shahed-238's engine exhaust, the hottest point on the airframe, where 60 kilowatts of near-infrared energy converts most efficiently into structural heating. The beam dwells for 3.1 seconds. The Shahed-238's turbojet combustion chamber reaches a temperature exceeding its operational limit. The engine fails. The airframe pitches down and impacts the Persian Gulf surface 3.8 nautical miles from Leyte Gulf at 21:53 hours and 44 seconds. First combat laser intercept in United States Navy history. The Helios operator does not pause. Beam slews to the second contact, 0.4 seconds transition. Dwell 3.1 seconds. Second contact incapacitated at 21:54 hours and 02 seconds. Third at 21:54 hours and 18 seconds. The Helios works through the surviving contacts with the mechanical consistency that defines a directed energy weapon. No reload cycle, no magazine to manage, no minimum safe firing interval. There is a cooling system maintaining the laser head at operating temperature, a power conditioning system drawing from the Leyte Gulf's electrical grid, and a beam quality monitor confirming coherence before each engagement. Fourth contact. Fifth. Sixth. Seventh. The Helios incapacitates all remaining Shahed-238 SS between 21:53 hours and 44 seconds and 21:55 hours and 22 seconds. 9 contacts total in 98 seconds of continuous engagement. The beam quality monitor shows 94.1% coherence at conclusion. The cooling system has not required a stabilization pause. 9 combat engagements. 9 incapacitations. At 21:55 hours and 22 seconds, 8 minutes and 10 seconds after the first SPY-6 acquisition, the threat picture is clear. 42 Shahed-238 contacts launched from 3 separate Iranian coastal positions. 21 incapacitated by SM-2 Block IIIB. 11 by ESSM Block 2. 9 by Helios directed energy weapon. 0 contacts reached the Eisenhower strike group's inner defensive perimeter. The carrier herself was never engaged by any defensive system. All 42 contacts were addressed in the outer and terminal layers before any approached the carrier's engagement zone. The Eisenhower's crew notes the engagement from 18 nautical miles. SM-2 and ESSM intercepts visible as brief flashes on the northern and western horizon. The Helios engagements leave no visible signature. A directed energy weapon fires light, not fire. The carrier has not maneuvered. Her flight deck crew is completing the pre-dawn maintenance cycle, preparing aircraft for the 0430 morning launch, uninterrupted by the 8-minute engagement 18 nautical miles to the northwest. Now, let us address what the Shahed-238 represents and why tonight's result, while operationally decisive, reflects a genuine engineering competition that cannot be treated as concluded. The Shahed-238's turbojet propulsion is a real capability improvement that fundamentally changes the engagement timeline available to surface-based defenses. Its radar cross-section of approximately 0.04 square meters is smaller than the Shahed-136's approximately 0.06 square meters, a reduction benefiting from the more streamlined fuselage required for higher speed flight. Its GNSS inertial guidance includes what Iranian engineers describe as improved anti-jamming capability in the terminal phase, directly addressing one of the primary countermeasures employed against the earlier variant. Against a defending force without the SPY-6V3's 67 nautical mile detection range, against a legacy SPY-1B detecting the Shahed-238 at 25 nautical miles, the engagement timeline compresses to approximately 2 minutes and 15 seconds, which is insufficient to complete 21 SM-2 engagements before lead contacts reach the inner defensive ring. The Shahed-238 was designed for exactly that compressed timeline. What its designers could not design against is a radar that detects it at 67 nautical miles. And that is exactly what the SPY-6V3 provided tonight. The SPY-6V3's sensitivity improvement over the SPY-1B is not marginal. It is the result of a development program that identified small, low observable, unmanned aerial threats as the primary air defense challenge of the coming decade, and engineered the solution before the threat fully materialized. The Shahed-238 encountered the radar it was never supposed to face at the detection range its doctrine assumed it would never contend with. The Helios combat debut adds a dimension that Iranian drone saturation planners must reconsider in their next doctrinal update. One SM-2 Block IIIB costs approximately $800,000. One ESSM Block II costs approximately $1.5 million. 9 ESSM rounds that would have been expended without Helios represent approximately $13.5 million in preserved missile inventory. Inventory the strike group needs for sustained operations over a multi-week deployment. The Helios engagement of 9 contacts cost the electrical power consumed by 60 kilowatts for 98 seconds of engagement. The economic logic of directed energy terminal defense, demonstrated in combat for the first time tonight, is visible in that comparison. A weapon that costs the price of electricity to fire, drawing on the ship's electrical systems, replacing missiles costing $800,000 to $1.5 million each, is not a tactical novelty. It is a strategic shift in the cost calculus of aerial saturation attacks against American naval forces. Iran's operational planners will receive the results through their own damage assessment. The absence of impact reports from 42 launched Shahed-238 UAS. Radar tracks from Iranian coastal monitoring showing all 42 contacts disappearing before reaching their target. They will study the geometry, the timing, the weapons used. They will assess the Helios's engagement range and rate. They will develop countermeasures. The engineering competition between Iranian offensive, unmanned systems and American defensive directed energy systems has entered its next iteration. But tonight's iteration belongs entirely to the defense. 42 of Iran's fastest and most capable one-way attack weapons in the most sophisticated coordinated saturation employment in IRGC Aerospace Force history were engaged across 3 defensive layers in 8 minutes and 10 seconds. The outermost layer addressed half the salvo before the second layer ever fired. The terminal layer fired a weapon that had never before been used in combat and achieved a perfect engagement record. The Eisenhower strike group expended 21 SM-2 rounds, 11 ESSM rounds, and 98 seconds of Helios laser time. Nothing penetrated the inner defensive perimeter. The Helios cooling system is at nominal operating temperature. The beam quality monitor shows 94.1% coherence. The operator has logged 9 combat engagements in the system's maintenance record and returned the weapon to standby readiness. He is at his station. He is waiting. The Persian Gulf radiates the day's heat through the night in ways that make the air shimmer above the water, even at 2200 hours. The Eisenhower is at 18 knots on her patrol heading. The Leyte Gulf is reloading her SM-2 and ESSM magazines from the pre-positioned ammunition queue established before this deployment began. Iran fired 42 of its newest, fastest, most capable one-way attack weapons at the most powerful carrier strike group in the Persian Gulf. None of them reached their target. 9 were incapacitated by a weapon that cost the price of electricity to fire. The first combat use of directed energy defense in United States Navy history. 9 for 9. Bye for now.